All right, guys, here's a quick video on the disc and washer versus the shell method. Both of these are used to find the volume of revolution. The first one, disc and washer, is what I taught you in AB. This is pi r squared. We're used to that. And then the new method from BC this year is the shell method, which is 2 pi rh. And like kind of the difference is here you're adding up a bunch of circles, right? Pi r squared is the area, and then you add them up to get volume. This guy right here, 2 pi RH is the formula for the surface area of the outside of a cylinder. And so like we're taking those cylinders, we're adding the outside plus the outside plus the outside plus the outside plus the outside like the Russian nesting dolls like we talked about in class. Okay, fine. So if we're finding the volume of the orange stuff being rotated around the y-axis and we do it the old method, disc and washer, well, we got to say, well, the entire shaded region is not touching the axis of rotation. So I need to find the volume of the solid and then subtract away what I don't want. Well, if I'm going around the y-axis, I have to have x equal stuff with y and use y limits. So that's what that's about right there. Okay, and then obviously I have to square root both sides to get x equals stuff with y. Now, I'm looking at it like this, right? Kind of like sideways. So if I find the solid, it's like rotating 2 around. So that's what's happening there. And I'm subtracting away, well, I don't want the white stuff, okay? And the white stuff can be expressed as the square root of y, right? The distance between here and here is the square root of y. All right, fine. So there's our setup. And then that's obviously 4, so 4y, that cancels to just y, so 1/2 y squared, and you guys can plug and chug on your own. All right, so the shell method, we can find the volume of that stuff being rotated without changing it to x equals stuff with y. So what's going to happen here is like, I got this little tiny sliver and I'm going around the outside of it, okay? I'm not like filling in to the x-axis like I would have with a disc and washer. It's just the outside, plus just the outside, plus just the outside, etc. Okay? And so the surface area formula for each of those cylinders that I'm finding essentially is 2 pi RH. Now, in this case right here, the R, like that black line is just like a random distance in. So this distance here is my R, okay? And that's an X value right there, all right? And then the distance up right here, that H right there is essentially just plugging C into the equation. That's giving me my H value. And so in this case right here, 2 pi, that right there, that's my R value. That's the distance to the C or the distance to the 2 or whatever. And then this X squared right here, well, that's standing for the purple graph. Like that's the height, right? That's just me plugging a 0, me plugging a 0.5, a 1, a C, whatever in, okay? And so we have our setup there. That's obviously x cubed, so bump up and divide. And you get your integration box and you plug and chug. And you can see the answers are the same, all right? In the next video, I will make one where this right here has like a plus or a minus with it, just to see how you shift it.